Well, in this problem, we'll try to solve this problem from Virginia Tech Math Competition, 1980. So what we have in this problem is a set that has a binary operator and also has this property that says whatever value you have in the middle, in this position, so you can just cancel them and then be left with the leftmost um, the leftmost element you multiplied with and the rightmost element. Um, for that reason, I'm going to refer to this property as the cancellation property. Okay, so what the question says is that what the question says is that given A times B is C, show that C times C is C. Okay, scratch work. Okay, so first, first let's just rewrite that over here. We have A times B equals C. This is what we are assuming. And if I somehow can turn this to C times C, then we're done since this is C, right? And that's exactly what I will try to do. So what we have is that C equals A times B, and then using the cancellation property, I can rewrite this as A times anything, and then anything times B, right? Because they're gonna these values are gonna end up canceling, and then you'll just be left with whatever you started with. In this case, A times B. Okay. So what I will try to do is have this BC, right, and then have that BC, if I can. Which you'll see in this problem we can. So A times B, let's just put B over there, and then let's put A over there. And then we see that A times B from the assumption is C, and then A times B is C. So we have it proved. And then to turn this into a formal proof, what I will do is I'll just replace this word with proof, and then the method we're using is direct proof. Okay, and then what we're doing initially is we're assume that A times B equals C, right? C equals C. And then and then everything just follows from there. So we're done. Okay, let's go on to B. Okay. For B, we assume the same thing, but we get a different result. Okay. So scratch. Okay. And then first, let's see. Let's write A times X. Okay. With C times X, right? No, that's what we want to show. We have A times X, and then I'm going to, like I did in the first problem, I'm going to use the cancellation property to rewrite this as A times anything equals A anything times X, right? And then in here, if I put in B, I get C, right? Okay, that's what I will do. And then this one, I'm just gonna keep it as I don't know what to put over there yet. So, and then this C from the first problem, since we assume the same thing, we can use this property. That means we can rewrite C as C times C, and then we have C times anything times X, and then this by the cancellation property, since these two cancel, we get C times X, and that's exactly what we wanted to show. And then like I did in part A, going to do the same thing to turn this into a formal proof. I'll replace the word, just scratch with proof. Okay, this is not cooperating. Okay, proof proof, and then this is direct proof, and then we assume that A times B equals C. And then notice that, like, well, whenever I'm saying times, I'm referring to this binary operator. I'm not talking about the product operator we're used to. And then I guess I kind of have to also say A, B, C, and X are in S, right? Yeah, and then this X is for any X. Okay. Right. Yeah. And then yeah, we're done. Then what I think I forgot to do the same thing for this problem, right? We have to first start with A, B, and C, and S, and everything follows.